In this video, we're going to take a look at what are called the double angle formulas or double angle formulae. Okay, and we're going to start with sine 2x as the first one, and we're really going to come up with this formula using what we learned in the previous lesson about compound angle formulas. So I hope once I show you that you could take sine of 2x and you could write that as sine of x plus x. I hope it makes sense to you that then I could apply the sine x plus y formula, right, where I'm adding two angles together and taking the sine of it, and I would then get sine x cos x plus cos x sine x. Okay, so I'm just applying that compound angle formula from the other day. And hopefully you can see once I apply that really, those two terms are the same. And so really I just have two of them, 2 sine x cos x. Okay, and that's our first double angle formula. So the first double angle formula is sine 2x equals 2 sine x cos x. So what would be great right now is if you tried to apply the same ideas and tried to come up with the formula for cos 2x and tan 2x on your own. So pause the video and even just try cos 2x. Okay, so same idea. I'm going to take cos 2x and I'm going to write it as cos of x plus x. And I'm going to apply the compound angle formula for cos x plus y. The angles are just the same. So that would give me cos x cos x minus sine x sine x. And I hope you can see how this is cos x squared minus sine x squared. And I hope you remember, perhaps from last year, that the way we write that is we actually write cos squared x. So that means the same thing, and that's the proper way to write that. Hopefully you remember seeing that before. And there's your double angle formula for cos 2x. Again, pause the video and try tan 2x all by yourself. Okay, so I've written it as tan x plus x, and then I'm going to use my formula for tan x plus y, and it would be tan x plus tan x all over 1 minus tan x tan x. And I hope you can see how that simplifies to 2 tan x all over 1 minus tan squared x. And so there's your formula for tan 2x. Okay, and if you recall seeing this Pythagorean identity before, sine squared x plus cos squared x equals 1, I think you've seen it before. It's definitely come up in conversation in class as well. It can, of course, be written in two other ways as well. I don't memorize those. I just remember the main one, and then I can always rearrange. So using that Pythagorean identity, there's actually two other formulas for cos of 2x, and I'll just show you. Basically, we're going to replace either the cos squared x or the sine squared x. So we'll do one here on the left. So first one over here, I'm going to replace the cos squared x. So what I mean by that is we have cos 2x equals cos squared x minus sine squared x, that's from above. And I'm going to go ahead and I'm going to replace cos squared x with 1 minus sine squared x. And then I'm just going to simplify what I have here. So hopefully you can see we have 1 minus sine squared x minus sine squared x. Those two are like terms. And so we end up with 1 minus 2 sine squared x. So one other formula for cos 2x. Okay, and similarly, I'm going to do the opposite on the other side. So here I'm going to replace the sine squared x, and I'll show you what that looks like. So same thing, cos 2x from above equals cos squared x minus sine squared x, and then I'm going to go ahead and I'm going to replace the sine squared x with 1 minus cos squared x, and I'm going to expand and simplify. And those are your double angle formulae. Okay, so there are 5 of them, one for sine 2x, one for tan 2x, and then there are 3 different options for cos 2x. You can go ahead and add those to your formula sheet, and now we're going to work on using these formulas to evaluate trig expressions. Okay, so in this first example, we're going to take a look, just like we did with the compound angle formula, at recognizing which one it is and then applying our knowledge. I hope you can see in this first one that the issue would be I could not find an exact value for sine of pi over 8 or cos of pi over 8. That's not one of our special triangles. But if we can look at this and see it as the double angle formula for sine 2x, then we can see that this is really just sine 2 of that angle, which is pi over 8. So basically, I'm using that formula from above, and I'm recognizing in the right side of that formula that x is pi over 8. So that means on the left side of the formula, it would be 2 times pi over 8, which conveniently simplifies to pi over 4. Okay, so I'm just applying the formula, in this case going from right to left, if that helps you to see it. And then I end up with just sine of pi over 4. And we know from our special triangles already that's 1 over root 2 or root 2 over 2 rationalized. Okay, so it helps us to find those exact values. Pause the video for a minute and see if you can do B all by yourself. Okay, so I hope you can see that that's the formula for cos 2x. Okay, and in this one then it simplifies to cos of pi over 3. And again, from our special triangles, we know that that equals 1 over 2. Okay, here's a couple more. Again, I will really encourage you to pause the video and try just looking at your formulas to see if you can recognize the formulas. Okay, so pause and take a couple minutes and see if you can get those ones. Okay, so take a look and see how you did. Hopefully you could recognize those formulas. I will start to bring things a little bit together now and mix in compound angle formulae with double angle formulae just to make sure you can see what's happening there. Okay, so that'll be one thing that you will practice today. The next thing that you will see is a question similar to ones that we've done before. I hope that when you read example 2, if cos theta equals negative 2/3 and theta is in quadrant 3, and I'm asking you to find the exact value for sine of 2 theta and cos of 2 theta, I'm really hoping that when you read this, your instinct is to draw a diagram, okay, and find that third side of your triangle, and then it doesn't matter what I ask you. This is similar to the compound angle questions or even just the basic ones from the beginning of the unit, but here are just a little bit of different simplifying. So pause the video, set that up, and then come back and we'll find sine 2 theta and cos 2 theta together. Okay, so hopefully you agree with my diagram and you can see how that third side is negative root 5 in this case. And so then we just look at what we're being asked. So here I'm being asked for sine 2 theta. So I'm going to use my double angle formula. I know that that's 2 sine theta cos theta. And then from the diagram, I'm going to need sine theta. So we just figured out how we would get sine theta is negative root 5 over 3, opposite over hypotenuse in my triangle. And actually, we already knew that cos theta was negative 2 over 3. And then we are just simplifying here. We end up with 4 root 5 over 9. Nothing to rationalize, nothing to be done there. Okay, so now we're going to do cos 2 theta. And with cos 2 theta, I'll just do that one over here at the side. We have a couple of options. You can use any of the 3 formulas. It doesn't matter which one you use. Obviously, it just matters which information you're going to put in there. The one that always comes to my mind first is cos squared theta minus sine squared theta. So I'm going to use that one just to show you what that looks like. But all 3 will give you the same answer. Okay, so we know that cos theta is negative 2/3. That's already actually given in the question, squared. And then minus, and we know that sine theta is negative root 5 over 3, and that is squared. So we'll just go ahead and simplify here. We're going to get 4 over 9, subtract 5 over 9. When you square that, it becomes positive, but it was a subtraction sign. And then we end up with negative 1 over 9. Okay, you can try it with the other 2 formulas just to prove to yourself that you get the same answer. Okay, so we'll do one more question. This is a little bit of a more challenging question, and I'm just going to set that up for you. Okay, so in this question, we're going to use this double angle formula to find an exact value for sine of pi over 8. Again, emphasizing we don't know how to find an exact value for sine of pi over 8 using any of our special triangles or things that we learned in the beginning of this unit. But this is one way that we could do that, okay? So we're trying to find sine of pi over 8. In other words, our angle in our question, theta, would be pi over 8. And of course, I hope you can see that 2 pi over 8 2 theta, would be 2 pi over 8, which is pi over 4, which is always good because it relates back to a special triangle. So that's sort of the advantage here. So we're going to use this formula. So let's apply this formula. So I have cos of 2 pi over 8, which is, of course, cos of pi over 4, equals 1 minus 2. We have sine of pi over 8, and I'm going to write it like this as it's squared, just to emphasize. Hopefully you could see how we know this value, we know this value, we have this, we have a squared, and this is all we're really searching for. So it's almost like we're solving an expression for x, or we can call it y, or any value here, and we only have one unknown, so we just do opposite operations to try to find that. So just to show you that even a little more clearly, I'm just going to do a little bit of a substitution here, and I'm going to say let y equals sine of pi over 8, so I'm now solving for y, just so that you can see what I have. So I have cos of pi over 4, which we know the value for that. We'll go ahead and put it in a minute. 1 minus 2y squared. Okay, so here you can see your y, and I'm just solving for y. Okay, so we're going to do opposite operations. I'm going to start with putting in the value for cos of pi over 4. So we know that that's 1 over root 2 from our special triangle. This question is a little bit simpler if I use the rationalized form right from the beginning. So I'm going to write it as root 2 over 2 equals 1 minus 2y squared. Okay, and all you need to do now is all of your opposite operations to solve for y. Okay, so first thing I hope you're thinking to do is I'm going to move the 1 over to the left. So it becomes root 2 over 2 minus 1 equals negative 2y squared. Of course, lots of different ways to write this. If you want to write it a different way and you get to the same place, that's great as well. Okay, on the left, we're going to need a common denominator of 2, and then we get root 2 minus 2. When I make the common denominator, equals negative 2y squared. Then I need to get rid of my negative 2. That's going to get divided to the other side, so that moves to the bottom. So I have root 2 minus 2 over negative 4 equals y squared. Okay, again, could be written in a different order to get rid of that negative. It is possible. Then I just want y by itself. I'm going to take the square root of both sides. Okay, sometimes I would be considering the positive or the negative in this case, but since pi over 8 is a quadrant 1 angle, it's really just the positive in this particular case. So it's really just positive square root of root 2 minus 2 over negative 4. Okay, and so therefore then, sine of pi over 8 equals that. It's a little bit messy looking, but it does just give you a decimal value, like if you punched it into your calculator. Okay, so you're going to practice a couple of those. It's definitely a little bit of an application of the double angle formulas, but there'll be lots for you to practice.